All right, so we've looked at solving by graphing, solving by factoring. Now this is another method that cannot be used all the time, but it's useful whenever we have no b term. So anytime b equals 0 and we have no linear term. All right, so just to review a bit, remember anytime we're talking about a quadratic function, we're talking about y equals ax squared plus bx plus c. It's important that you realize the function is when we have the y equals. That's usually when we like to graph. Now, a quadratic equation is when we take that same function and we set y equal to 0, and then we solve using different methods. So far factoring, and then today we're going to look at square rooting. So remember, so far we've talked about the different types of roots or solutions you can have to a quadratic equation. All right, remember that means that whenever I'm looking at the graph, if I have two solutions, that means my parabola hits the x-axis twice. If I have one solution, that means my parabola is sitting on the x-axis, just the vertex is touching. And if I don't touch the x-axis at all, I have no real solutions or no real roots. So we looked at graphing as one way to do it. Remember, we graph and then we look at wherever the parabola hits the x-axis. So here, the solutions would be -1, 5. So those would be my zeros. Remember, you can also write it as x equals -1 or x equals 5. We also looked at how to solve by factoring. So if I wanted to factor this guy and solve, I would go ahead. This is a difference of perfect squares. So that'd be x and x. Square root of 9 is 3. 1 negative, 1 positive, all equal to 0. So then I would set each individual binomial equal to 0. So x minus 3 equals 0. And solving, that would give me x equals +3. X plus 3 equals 0. Solving, that would give me x equals -3. So there would be my solutions. Now notice, in this particular equation, I have no linear term. There is no b term. All right. Now anytime this happens, there's another way to solve this type of equation that might be easier and will also work even when this is not a perfect square. So the square root property, pretty much what the square root property says is that I am allowed to take the square root of two sides of an equation as long as I take into account that when I physically draw the square root symbol, I'm getting plus and minus that solution. So anytime I am missing a linear term, I don't have my b term here, I'm allowed to use the square root property. So looking at this, what numbers can I square and get 25? Well, I know that 5 squared is 25, right? Well, is there another number that when I square it will give me 25? There is. -5 squared will also give me 25. Okay? So you can see that there's two solutions there. There's 5 and -5. So anytime I do not have a b term, there's no linear term, I can use the square root property. All right? And what that says is that once I have the squared term isolated, I can take the square root of both sides. And remember, square root and square, so this square root and this square term will pretty much cancel each other out because I will simplify this and the x will hop out. So that's x equals, well, what is the square root of 25? Well, the square root of 25 is 5, but remember, I have to take into account that positive and negative value that I can square. So remember, because 5 squared is 25 and so is -5 squared, I have to have both of those as my solution. So just as a rule of thumb, anytime you are physically drawing the square root, I'm drawing the square root on both sides, that's when you take into account the positive and negative value for the square root. So for instance, if I said, what is the square root of 4, and I gave you that problem as is, the correct answer would be 2. Because if I just give you the square root of 4, I'm asking you for what's called the principal square root, which is just the positive number. But if I were to give you a problem that said x squared equals 4, and then I asked you to solve, and you physically drew the square root, that's when you have to factor in the positive and negative values for x. And in this case, it's okay to put x equals plus or minus 2, because if you see when I say that symbol, when I say this symbol, I say plus or minus. So I know that I'm stating the or. If you want, you can break it up though. So I could also write it as x equals 2 or x equals negative 2, or I can do the brackets, whichever one you prefer. Alright, so let's go through the steps to taking a square root. The first step is to isolate the square term. Now when I say square term, I mean you want to get it until it looks like x squared. You cannot have anything in front of it. You can't have anything added or subtracted. Okay? You just need that x squared term completely alone. So I'm going to move stuff around a little bit over here, right? I need to move the negative 9 over, so I'm going to add 9 to both sides. So 16x squared equals positive 9. Now, I still have something attached to the x squared, right? It has to be alone first. So how do I get it alone? Well, I divide each side by 16. These go away. So I get x squared equals 9 over 16. Now that my squared term is isolated, I take the square root of both sides. So that's step 2. Take the square root of both sides. Okay, hopefully you remember how to do this. So remember the x squared and the square root kind of cancel out. So that's x equals. Hopefully you remember how to simplify this. So that's going to be the square root of 9 over the square root of 16, which is 3/4. But do not forget that plus or minus. I have 2 solutions there, the positive and the negative value. So that's super important. If you forget the plus minus, you're leaving off an answer. And you can go ahead and plug these in and check. You would plug them into the original equation and you would check to see that they in fact work. They make it 0 equals 0. Alright, so now we're going to do some practice. Now remember I said that first step is to isolate the square term. So here I just need to take away 144 on both sides. That will isolate x squared. So x squared equals negative 144. Now I need to square root both sides of the equation. Okay, remember when I draw the square root, that means I need to do plus or minus. Now simplifying the square root of negative 144, remember the negative underneath the radical here. This guy means that there's an imaginary number. So I need to pull that I out. So that's going to be x equals plus or minus. The square root of 144 is 12. So it's going to be 12i. So there are 2 imaginary solutions there, right? There's negative 12i and positive 12i. And the fact that there's an imaginary solution means that if you were going to graph this, your parabola would not hit the x-axis. It would float above or below the x-axis. It would never intersect. So down here it looks a little different, right? Remember, step 1 was isolate the squared term. Now in this case, the squared term is this entire term. So this whole thing is the squared term. Now how do I know if it's isolated? Well, there's nothing in front of it. There's nothing multiplied to it. There's nothing added or subtracted on the back of it. So I know it's isolated. So I'm going to go ahead and take the square root of both sides. Remember the square root and the square cancel each other out here. So I'm left with x minus 4 equals plus or minus the square root of negative 25. Now, isolating x, I'm going to add 4 to both sides. So coming up here, I get x equals 4 plus or minus the square root of negative 25. Well, what is the square root of negative 25? Well, that means the negative means I have an I. And the square root of 25 is 5, so that's 5i. So there are my 2 solutions. I get 4 plus 5i and 4 minus 5i. Okay, so again, a couple more extra examples. Remember, our squared term needs to be isolated. It is in this case, so I'm going to go ahead and square root both sides. Since I'm drawing the square root, I need to do plus or minus. Now, the square root of 7 cannot be simplified. Therefore, that's it. That's my solution. Down here, I need to isolate the x squared term, so I'm going to add 49 to both sides. So I get 9x squared equals 49. Now remember, I still need to isolate my x squared term. There's a 9 connected to it right now, so I need to divide each side by 9. x squared equals 49 over 9. Now I'm going to take the square root of both sides. Since I'm drawing the square root, I have to remember to put plus minus. Now remember, I can break this up into the square root of 49 over the square root of 9, both of which are perfect squares. So that's going to be x equals plus or minus 7 over 3. And those would be my answers. That's 2 answers there, right? And you can go ahead and plug them in separately into the equation to see that they work. Alright, so here are some examples for you to try. Go ahead and label them A, B, C, D, E in your Google form and give them a shot.